This video continues with the sum and difference identities, using some different examples to demonstrate how to use these identities. Before we looked at things like find cosine of 105 degrees exactly, but we could also ask the question like this: find cosine of 3 pi over 4 minus pi over 3 exactly. Again, when we see the word exactly, that means don't touch your calculator. You need to use your trig identities. If what we're trying to find is in the form of alpha minus beta, like we have here, then we'll use this difference identity. Cosine of alpha minus beta is equal to cosine alpha cosine beta plus sine alpha sine beta. In this case, alpha is equal to 3 pi over 4, and beta is equal to pi over 3. We're going to need to refer to our unit circle to remember what cosine of 3 pi over 4, cosine of pi over 3, and sine of 3 pi over 4, and sine of pi over 3 are. So if we go to our unit circle, we remember that sine of pi over 3 is equal to square root of 3 over 2, cosine of pi over 3 is equal to 1/2, and sine of 3 pi over 4 is square root of 2 over 2, and cosine of 3 pi over 4 is negative square root of 2 over 2. Going back to our difference identity, we have cosine of 3 pi over 4 minus pi over 3 equaling negative square root of 2 over 2 times 1/2 plus square root of 2 over 2 times square root of 3 over 2. Doing our multiplication and then adding, we find that cosine of 3 pi over 4 minus pi over 3 is equal to negative square root of 2 plus square root of 6 all over 4. You could also be given a question like this, which looks pretty complicated at first glance. Finding cosine of 42 degrees, cosine of 18 degrees, minus sine of 42 degrees, sine of 18 degrees exactly doesn't seem possible since we don't know cosine or sine of 42 degrees and 18 degrees. This is when we're going to have to use our sum and difference identities backwards. If we go back to our summary of trig identities, you see that what we have looks an awful lot like the right-hand side of our cosine of alpha plus or minus beta. So if we use that, and if you notice that this expression is in the form of cosine alpha cosine beta minus sine alpha sine beta, then we can say that this whole expression is simply equal to cosine of 42 degrees plus 18 degrees. Again, that might not seem helpful until we go ahead and add together 42 and 18, and that leaves us with 60 degrees. Well, we know what the cosine of 60 degrees is. The cosine of 60 degrees is equal to 1/2. So the cosine of 42 degrees times the cosine of 18 degrees minus the sine of 42 degrees times sine of 18 degrees is exactly equal to 1/2. Okay, here's another example, and this one looks even worse. Find the tangent of 80 degrees minus the tangent of 35 degrees all over 1 plus tangent of 80 degrees times tangent of 35 degrees. Again, we're going to use our trig identities backwards. We're going to look at the right-hand side of this and figure out which sum and difference identity this matches. Well, this matches our tangent sum and difference identity. And since we have the form tangent alpha minus tangent beta in the numerator, we know that we're going to need the tangent of alpha minus beta, that is the difference identity for tangent. Plugging in the values of alpha and beta, we find that tangent of 80 degrees minus tangent of 35 degrees over 1 plus tangent of 80 degrees, tangent of 35 degrees, simply equals tangent of 80 degrees minus 35 degrees, or tangent of 45 degrees. And tangent of 45 degrees is just equal to 1. So that whole mess up there just equals the value 1 exactly. One final type of problem you can be given is find cosine of u plus v exactly if we know sine u is 3 over 5 and sine of v is 12 over 13. And we're given that both u and v are acute angles, that is, they are in quadrant 1. There's two different ways we can solve this. Well, if we know that we need to use our cosine sum identity, and we'll have this form, we know we need to find what cosine of u and cosine of v is. Well, let's first look at cosine of u. Here I've replaced alpha and beta with u and v, and if we remember our Pythagorean identity, sine squared of u plus cosine squared of u is equal to 1. Well, I know sine of u, that's 3 over 5, If I square that and add it to cosine squared u, that should equal 1. If I go ahead and square those, I get 9 over 25. If I subtract 9 over 25 from both sides, then I get cosine squared u equals 1 minus 9 over 25. I'll find a common denominator, I'll do the subtraction, and I find that cosine squared u is equal to 16 over 25. Well, if what I want is cosine of u, I'll take the square root of both sides, and cosine of u is simply equal to 4 over 5. Now I have cosine u, now I need to find cosine of v. And this time, instead of using the Pythagorean identity, I'm going to go back and use a skill that we learned in the very beginning of the class, just to show you that you can still rely on the skills you learned in the first half of the class. I can go back to drawing triangles. If I have this angle v, and I know that sine of v is 12 over 13, that means my opposite side is 12 and my hypotenuse is 13. I can simply use Pythagorean's theorem to find my missing side. Something squared plus 12 squared is equal to 13 squared. If I go ahead and do my squares, subtract 144 from both sides, I find that that missing side squared is 25, or that missing side is length 5. If I know the opposite side is 5 and the hypotenuse is 13, then the cosine of v is simply 5 over 13. You can solve for cosine u and cosine v either method, whichever one is easiest for you. If I go ahead now and use my cosine u and cosine v and sine u and sine v into my sum identity for cosine, then I get 4 over 5 times 5 over 13 minus 3 over 5 times 12 over 13. Multiplying that out and going ahead and doing the subtraction, I get cosine of u plus v equaling negative 16 over 65. And there we've done some different examples using our sum and difference identities for cosine, sine, and tangent.